day everyone. Our lesson today about square root. So our objectives are the following. First, describe principal roots and tells whether they are rational or irrational. Second, determine between what two integers the square root of a number is. Third, plot irrational numbers on the number line. Let us recall that the rational number is expressed as a fraction or decimal. Every terminating or non-terminating repeating decimal represents a rational number. Examples, we have -8, 12, -112, 2/3, -7/5, 2 and 75 hundredths, -1 and 2 hundredths. We have a repeating decimal which is 0.3333 and so on. A repeating decimal which is 1.242424 and so on. And a repeating decimal which is -2.542542 and so on. So these are the examples of rational number. Now, we have irrational numbers. And what are irrational numbers? Irrational numbers are numbers that cannot be expressed in fractions, which are non-terminating, non-repeating decimals. So, examples, we have these 0.123452331 and so on. So, this is an example of non-terminating, non-repeating decimal. And the value of pi. So it is non-terminating, non-repeating decimal. That's why pi is an example of irrational number. Then we have this -3.4561237 and so on. So this is an example of non-terminating, non-repeating decimal. So therefore, these three numbers here are examples of irrational numbers. Now, what is a square root? So, a square root of a number is a number when multiplied to itself will give you the original number. So, for example, the square root of 16 are +4 and -4. Because when +4 and -4 are multiplied to themselves, they are equal to 16. So, 4 times 4, it is equal to 16. And -4 times -4, it is also equal to 16. So, therefore, the square root of 16 are +4 and -4. So, if the square root of a number is non-terminating, non-repeating decimal, so it is an irrational number. And every positive number has two square roots. One is positive and the other is negative. And the principal square root is the positive square root of the given number or radicand. And the principal square root is rational if the radicand is a perfect square. If not, then the principal square root is irrational. So 0 has only one square root, which is 0. And negative numbers do not have real square roots. So their square roots are called imaginary numbers. So for example, we have the square root of -10. So it is an imaginary number because the radicand is a negative number. Now, let us have example. Let's say we have task 1A. Tell whether each of the following is a rational or irrational. And if it is rational, give the principal root. So, take note that the principal root is the positive root of a given square root of a number. So, let us have rational or irrational and then the principal root. So, let us have number 1. So, we are given square root of 4. So, can we give it as a rational or irrational? So, it is rational because there is a particular number that when you multiply it to itself, it will give a product of 4, which is equal to 2. So, the principal root is +2. Okay? But we have two roots. We have positive 2 and negative 2, because when we multiply positive 2 to itself, it will give a product of 4, and negative 2 to itself, it will give a product of 4. But the task only asks for the principal root. Now we have the square root of 10. So it is an irrational number because there's no such number that when you multiply it to itself, it will give a product of 10. Now let's have square root of 81. So this is rational number. Why? Because the principal root is positive 9. When you multiply positive 9 to itself, it will give a product of 81. So 9 times 9, or positive 9 times positive 9, it is equal to 81. And we have number 4, square root of 75. So this is an irrational number because there's no such number that when you multiply it to itself, it will give a product of 75. Now let us have example task 1B. So between which two consecutive integers does the square root lie? So let us have number 1, square root of 130. So 130 lies between the consecutive perfect squares 121 and 144. Take note that we call this as perfect squares because when a number is multiplied to itself, the product is a perfect square. So we have 121 because this is simply 11. When you multiply 11 to itself, 11 times 11, it will give a product of 121. And this is also a perfect square because there is such number that when you multiply it to itself, it will give a product of 144, and that's 12. So 12 times 12 is equal to 144. So we can have this inequality relationship that 130 is greater than 121 but less than 144. And if we get the square root of this, so the square root of 130 is greater than the square root of 121 but less than the square root of 144. And the square root of 121 is 11, and the square root of 144 is 12. So we can read this as the square root of 130 is greater than 11 but less than 12. So therefore, the square root of 130 lies between 11 and 12. Now let us have example number 2. So we are given the square root of 72. So 72 lies between the consecutive perfect squares, which are 64 and 81. So they are perfect squares because there is this number that when you multiply it to itself, it will give a product of 64 and 81. And that's 8 times 8, which is 64, and 9 times 9, which is 81. So we can have this relationship that 72 is greater than 64 but less than 81. And we get the square root. So the square root of 72 is greater than the square root of 64 but less than the square root of 81. And then the square root of 72 is greater than 8 because the square root of 64 is 8 but less than 9 because the square root of 81 is 9. So we will read this as the square root of 72 is greater than 8 but less than 9. So therefore, the square root of 72 lies between two consecutive integers which are 8 and 9. Now let us have example number 3. So we have here the square root of 14. So 14 lies between the consecutive perfect squares which are 9 and 16. So they are perfect squares because there is this number that when you multiply it to itself, the product is 9 and 16. So for 9, we have 3 times 3, so it is equal to 9. And 16, we have 4 times 4, which is equal to 16. So therefore, 9 and 16 are perfect squares. So we have to get this relationship that 14 is greater than 9 but less than 16. And if we get the square root, so we have the square root of 14 is greater than the square root of 9 but less than the square root of 16. And if we get the square root, so we will have the square root of 14 is greater than the square root of 9, which is 3, but less than the square root of 16, which is 4. So therefore, the square root of 14 is between two consecutive integers, and these are 3 and 4. Now, let's have example number 4. So, we are given square root of 251. And 251 lies between the consecutive perfect squares, which are 225 and 256. So, they are perfect square because there is this such number that when we multiply it to itself, it is equal to 225 and 256. So we will have this relationship symbol that 251 is greater than 225 but less than 256. So if we get the square root, so the square root of 251 is greater than the square root of 225 but less than the square root of 256. So let us simplify. So the square root of 251 is greater than the square root of 225, which is equal to 15, because 15 times 15 is 225. But less than the square root of 256, which is equal to 16, because 16 times 16 is 256. So therefore, we have this, the square root of 251 is greater than 15, but less than 16. So therefore, square root of 251 lies between the two consecutive integers, which are 15 and 16. Now, let us have this example. Let's say we have task 1C. Estimate the square root to the nearest hundredth and plot the square root in a given number line. So let us have example number 1. So we are given the square root of 147. So the principal root of square root of 147 is between 12 and 13. It is closer to 12 because when we get the square of 12, or simply 12 times 12, it is equal to 144. And the square of 13, or 13 times 13, it is equal to 169. And 147 is closer to 144 than 169. So therefore, the square root of 147 is closer to 12. So by estimation, since the square root of 147 is closer to 12, so we can have an estimation that it is closer to 12.1. So to the nearest tenths muna tayo, because our objective is to find the square root to the nearest hundred. So nearest tenth muna tayo. Since it is closer to 12, so let us choose 12.1. And if we get the square of 12.1, or simply 12.1 times 12.1, so it is equal to 146.21. And then we will find also the next consecutive number to the nearest tenth. So after 12.1, which is 12.2. So 12.2 square, or 12.2 times 12.2, it is equal to 148.84. And square root of 147 is nearer to 12.1. Why? Because 146.21 is closer to 147 than 148.84. So continuing the estimation to the hundredth placed, so we will have, since it is closer to 12.1, so we will choose a decimal number to the nearest hundred, which is closer to 12.1, and we choose 12.8. 12.11. So this is the 100 place. So 12.11 is closer to 12.1. So we get the square of 12.11 or 12.11 times 12.11. So it is equal to 146,521 ten thousandths. Okay, so the next one to the nearest hundreds will be 12.12. So we get the square of 12.12 or simply 12.12 times 12.12. So it is equal to 146.8,944 ten thousandths. So it is nearer to 147. So again, we choose the next one, which is 12.13. Because we are finding two decimal number to the nearest hundreds, which is closer to 147. So now let us get 12.13. So the square of 12.13 or simply 12.13 times 12.13, it is equal to 147.1369 ten thousand. So we can now find two decimal number to the nearest hundreds wherein 147 is between these two. Okay, so we choose 12.12 and 12.13. Now, 147 is closer to 146.8944 or 8,944 ten thousand. So therefore, the approximate square root of 147 to the nearest hundred is 12.12. Now, if we're going to plot it on a number line, so we have this number line. So take note that the number line, when we labeled it by the integers, so going to the right is increasing and positive. So we have 11, 12, 13, and 14. But since the approximate value for the square root of 147 is 12.12, so we will just approximate the location. And 12.12 is nearer to 12 than 13. So the location will be here. So this is the graph of the approximate value of the square root of 147. Now, let us have example number 2. So, we are given the square root of 425. So, the principal root of the square root of 425 is between 20 and 21. It is closer to 21 because when we get the square of 20, or 20 times 20, it is equal to 400. And 21 squared or 21 times 21, it is equal to 441. And we choose 21 because 441 is closer to 425. So by estimation, we will choose one decimal place value nearer to 21, so we can choose 20.6. Okay, because 20.6 is nearer to 21. So we will choose not greater than 21 but less than 21. So we want 20.6 because the square root of 425 lies between 20 and 21. So it will never be greater than 21. So therefore, we will choose 20.6. And if we get the square of 20.6, so it is equal to 424 and 36 hundredths. Now, the second one, wherein we can find the decimal number, and if we get the square, we can see it is in between 425. So we have 20 and 7/10. So if we get the square of 20.7 or simply 20.7 times 20.7, it is equal to 428.49. So this will be the two consecutive decimal number that we're going to consider, because 425 is between 424.36 and 428.49. Now let us choose which of these two is closer to 425. So we choose 20.6 because 424.36 is closer to 425. Okay? So continuing the estimation to the hundredth place. So we have, since we choose 20.6, so we will choose 20.61 to the hundredth place. And if we get the square of it, so it is equal to 424 and 7,721 ten thousandths. So again, what will be the next decimal number? So we will have 20.62, and the square of 20.62 or 20.62 times 20.62 is equal to 425 and 1,844 ten thousandths. So 425 is closer to 425 and 1,844 ten thousandths. So therefore, the approximate square root of 425 is equal to 20 and 62 hundredths. And if we are going to locate it on a number line, so we have this number line, so 18, 19, 20, 21. So 20 and 62 hundredths is nearer to the half between 20 and 21. So the location of the point, something here. So this will be the location of the point. So it is closer to 21 because it is passed through the middle of 20 and 21. Now let us have example number 3. So we have the square root of 700. So the principal root of the square root of 700 is between 26 and 27. And it is closer to 26 because the square of 26 is 676 and the square of 27 is 729. So it is closer to 26 because 676 is closer to 700. So we will choose one decimal place value nearer to 26. So by estimation, we can have 26.4. And if we get the square of 26.4, so it is equal to 696.96. And the next one, we have to find two decimal number wherein 700 lies in between these two. So we have 26.5 and the square of 26.5 is equal to 702.25. So which among these two is nearer to 700 or closer? So it is 26.5 because 702.25 is closer to 700. So continuing the estimation to the hundredth place. So we have, since it is closer to 26.5, so we will choose two decimal place number lower than 26.5. So we can choose 26.45. Then if we get the square of 26.45, it is equal to 699 and 6,025 ten thousandths. So the next decimal number to 100 placed, we have 26.46. So if we get the square of 26.46, so it is equal to 700 and 1,316 ten thousandths. So 700 is closer to 700 and 1,316 ten thousandths. So therefore, the approximate square root of 700 is equal to 26 and 46 hundredths. So the location of this on the number line, it is between 26 and 27, but it is closer to 26 before the middle of 26 and 27. So this will be the location of the square root of 700. Now let us have this task 2 example. So problem solving. So we are given this problem. Linda has a square picture which has an area of 912 square inches. So how long is each side of the picture to the nearest hundredth? So we have to get the approximate square root of 912 to the nearest hundred. So the first step, the principal root of the square root of 912 is between 30 and 31. So it is closer to 30 because we have this 30 squared, or this 30 times 30 is equal to 912. 31 squared is equal to 961. So we choose 30 and 31 because the square of these two numbers, or the product of these two numbers to itself, are 900 and 961. It is wherein we can find 912 between these two. So by estimation, we choose decimal number to tens place, nearer to or closer to 30. So we have 30.1. So the square of 30.1 is equal to 906.01. And the square of 30.2, the next decimal number to the nearest tens, we have 30.2 square is equal to 912.04. So which is closer between these two for 30.1 or 30.2? So it is closer, okay, 30.2 is closer to 912 because 912.04 is closer to 912. So continuing the estimation to the hundredth place of the square root of 912, we have closer to 30.2. So it means that we will choose decimal number to the hundredths place lower than 30.2. So we have 30.19. And the square of 30.19 or 30.19 times 30.19, it is equal to 911.4361. And then the next one is 30.20. Okay, then we get the square of it, so it is equal to 912.0400 or 912 and 410 thousandths. So 912 is closer to 912.0400. Therefore, the approximate square root of 912 is equal to 30.20. So therefore, the sides of the picture is approximately equal to 30.20 inches. So I hope that you've learned from this discussion. So thank you for watching and God bless. And do not forget to like, share, and subscribe for this video. Thank you.